Invite the stragglers to join, and let's see if we can kind of pick up where we left off last time. I'll share my screen. All right, so last I left it, we were kind of playing around with the standard in, standard out, and standard error. Okay, kind of keeping in mind where those three streams are at all times. They're always there. They may be empty. That's all right. Okay. So with that in mind, I think we should pick up assignment 3 and at least get you started on it. And that's going to bring up some issues, and we'll kind of tackle those as they turn up. So assignment 3. You're reading through the chapter, all that good stuff, and then you're downloading 3 files and then a bash program that I wrote. Okay. So to download these, obviously you can right-click them and say save link as, and then find it in your downloads folder and move it over to your assignment 3 project directory. Or we can go a bit galaxy brain and make this part of our actual reproducible aspect. So in that case, I can just copy the link location like so. All right, so I'm in my bioinformatics assignments on my desktop. I've got a folder for assignment 3. I'm going to go into assignment 3, look around, and I've got workflow there already. You don't have that. That's all right. But let's take a look at how we can download these. If I paste that in, that really is just a URL link to this FASTA file. Okay. I hit the home key, so I'm back over here at the beginning. And there's this command called wget. So you can say wget about anything on the internet. If it's a path to a file, you just get that and hit enter. I've got it. All right, so wget and then the path to the file online. Okay, you see HTTP request sent, waiting response. Okay, my internet's working fine. It's going to download that, and by default, it sticks it right where I am. So I've got file 1 right there like that. Reagan, I see your hand.
Yeah, it's telling me that wget is a command not found.
Man, you Mac people.
Anybody else?
All the troubles. Anyone else?
Yeah, I got that too, and I'm on Windows.
All right, well, let's get you the wget. Okay, so I did not anticipate that. wget for Windows. Let's make sure this is the right. Yep, that's it. Okay, so if you're on Windows, I'm pasting this in to the conversation. Looks like you can use brew if you're on the Mac. So brew install wget. Yeah, that's got to be it. Okay, update me. Is this working?
I think so. It's still downloading.
Oh, okay. How about Windows folks?
It worked for Mac, so.
Okay. It kind of shocks me that it doesn't come bundled with your bash, but learn something new every day. So this wget program is basically just like a little web crawler. It has a bunch of options for how to get stuff. Okay. So we can tell it like how deep to go. It can follow links within a website. And you could say, okay, follow 1 link deep, or 2, or 3, or 4. You could try to get the entire internet all at one go with wget if you really wanted to. So it's worth kind of just using the default options at first, because you can really start downloading terabytes of data on accident with this automatically. Is it still downloading for Windows?
Mine's working now.
Okay. Still downloading, all right. All packages require MS Windows 2000 with CRT DLL. Let's see.
I'm sorry. So what was the code that we were supposed to use for not Mac, for Microsoft?
Microsoft's not going to let you use code because it doesn't have that native Unix, and so you're going to have to download. You're going to have to go online, download it, and install a pre-built wget. Okay. Let me make sure I've got the right link for you. Yeah, okay, so that link that I put there, 836, the GNU Win, new Win 32. Click on this complete package except sources setup. Okay. Your download will start shortly. And this should be an exe. Okay, so you can run, download this file you see here, and run that, and that should set it up on your system. All right, and so Trevor, you said you got the error MSV cert.
No, my bash just won't run that command still.
Okay.
says command not found. So I don't know if I need to change the directory that downloaded to and installed to, or
We'll get there in a second. You probably will, but I want to
Okay.
make sure you have msvcrt.dll.
that was just in the install page on the very first.
Oh, okay.
So that, yeah, because it says it works with Windows 2000 XP, 2003, Vista, 2008, and 7, but it
Okay.
doesn't mention Windows 10 there. I don't know if everyone else is working on Windows 10.
Oh, right.
So I was just looking for another download, to be honest, but wget.
All right, so that's the same. That's the same link. Okay, so you've got it installed. You've got wget.exe on your system somewhere, right?
Yeah, it's somewhere.
Okay. Where is it? In downloads, maybe, or
Because I have the setup.exe in my downloads, but I don't know where it put the other one. Would it be in my path?
that was going to be my next question. All
That's
right,
where it's
so
supposed to end up, right?
that's where you want it to be. Okay, so remember, if we type in echo $ capitals path, that's going to tell us the current value of our path. And what is the path?
I don't have a full theoretical understanding of the path, to be honest.
All right, it's just where your computer automatically looks for programs.
Okay.
So it's a list of directories, these paths here, separated by colons. And so when I type a program, my computer doesn't know what that is. It has to look for that program. Automatically, by default, it's going to look in this gzon bbmap. It's also going to look in .local bin and anaconda bin, local sbin. And so these are the locations that you've told your computer to look for programs.
Right.
So you're going to want to copy your wget.exe into one of those folders.
Doesn't it usually go in the bin? Or would I have that?
It honestly doesn't matter. Any one of these.
Will work.
So
Okay.
yeah, so you could put it in user local sbin or user local bin, user sbin. It doesn't matter. You're just going to want it to be there. So I'm going to take a look here at user local bin. And it's just a bunch of programs. That's all that lives in this directory. So these are binaries. These are the programs that your computer automatically knows about. So if I start, I can be anywhere on my computer and type in base mount and it will run because it knows to look for base mount in this file path. Okay, so you can stick anything you want in there for it to know about. So user sbin. There's a bunch more programs. Okay, so what you need to do now is get your wget.exe into one of those paths.
Okay. I can work on that alone so we don't hold up the class.
That's okay. You're not the only Windows user.
Yeah,
I'm
mine
sure
isn't
everyone.
working either
Okay.
Okay.
after installing it.
You're going to be using wget for the rest of your bioinformatics life, so you might as well
Get it done correctly.
get it done correctly, and here we are. This
So
is
I
actually
think
a class about this, so we're going to do it.
So I found where it put it, I'm pretty sure.
Okay.
And then how do I put it in a place where it will actually work?
How about you share your screen with
Yeah,
me? I'll stop sharing.
Oh, I got a lot of screens up.
All
This
right.
one.
What we're experiencing right now is something that's going to be happening a lot. As you install any bioinformatics software, it's not necessarily going to go into your bin where you need it. Okay. If you're on a supercomputer trying to get stuff installed, you're going to have a special little bin there on your U account, all that. And so this is important. So open up new Win32. Okay. And there you've got something called bin. That's your binary. Let's take a look there. Okay. It gave you sed and wget. Those are both applications. So I would highlight those two. Copy. I'm just wondering if we need all those libraries as well. We'll try this and we'll come back. Okay. Now, you need to go to, how do we get there in Windows? All right, just highlight wget and copy location. Yeah, just copy. Okay, now open up your terminal.
Okay, I have like a bunch of screens up, so it's only sharing half of my screen right now. Ooh, did I just lose you guys?
No.
What is being shared at this point?
That same screen with wget. If you do, if you open your sharing tray and do share whole screen instead of share window, sometimes that works better.
Okay.
Okay. So there's your paths. All right, I want you to type CP for copy. All right, and then paste in. So we're going to copy that file and then hit a space. And let's put it in /user/bin USR. Okay. Hit enter. Okay. Hit the up key. It's like, hey, you don't have permission. And now hit home to go to the front and type in sudo. This is a magic key. sudo and then space. All right. This sudo, or it's sudo sometimes pronounced, stands for super user do, and of course it's not going to work. So you don't have permission. Are you an administrator on your computer?
I believe so.
Okay. Try listing everything in user bin. Okay, yeah, you got a bunch of stuff in there. What the hell? Well, this kind of derails things. You've got awk, you've got kill. So this is where wget needs to be. Right there. All right, so maybe we can do this outside of the command line, back over there near like Finder tab.
Okay.
Try right-clicking wget and like there's a copy file to or send to. That's it. Okay.
And does it matter where I send it?
Yeah, it does.
Okay.
Let's see. Move to OneDrive. Come on now. Share with Skype. See, I'm used to there being a way for you to pick where to send it. All right. Well, you have it copied, right?
Mm-hmm.
All right. Up in your top bar there, where it's like this PC, Windows, program files. Can you go to the left there? Yeah. Let's. Yeah, this PC, I guess. Yeah. Okay. So let's see. It's not letting us find the root folder. Okay, it's in your C drive, which is confusing because your root actually isn't in your C. Your C is in your root, but they're doing this to us for some reason.
Okay.
So click on C. Okay, and then system root. Man, this is fun, isn't it? Just to run wget. Hold your Windows key and hit R to run, and then type in CMD to get your command prompt. This is different from your Unix terminal.
You said CMD.
Yeah. Okay, so this is the Windows version of a terminal, your command prompt. Try typing set and then system root as one word. Space, sorry, set space and then system root. All right. All right, so that's your root is Windows. So there in C Windows is where you want to be. So I think you can close your command prompt now.
Okay.
All right, go into Windows.
Back into that.
There on your screen, on the right. Yep. Windows. Okay, so this is where we're going to be looking for user bin. And it's not there. Man, I hate Windows.
Let's just all go download Linux.
Yeah, I mean, really should. You can do a side-by-side boot. I'm gonna have to find something outside of class time. This is going to take us like an hour or two.
Sounds good.
So for now, right-click those, save them, and move them into your folder from assignment 3. You Mac people,
Yeah, I've already saved them from there.
You Mac people can do the wget. Windows, you're going to want wget. Use it all the time in bioinformatics. You know, you're downloading files, software, all that kind of stuff. So we will find a way to get it for you. And your next laptop that you buy, when this one craps out, don't get Windows. It's just like a general rule. If you're doing scientific computing, it's just not going to work. All right, could you stick it in a place that's not the bin and create an alias to find it? Technically, you're going to want it to be there in your bin. You're not going to want to have to remember the aliases. Yeah. Not to mention anybody that comes after you to work on this same project, they can just put it in their bin and they won't have your aliases. And so, all right. Well, okay, that was really fun. Let's see here. Desktop, BINF assignments, assignment 3. Okay, so I got the first assignment file. I'm going to go ahead and get these other two. Copy link location, wget, paste it in. File 3, copy link location, wget, paste it in. So I've got my 3 files for assignment 3. Okay, now, unless you're on Windows, I guess, we can kind of automate that part, right? Because that's part of the analysis, is downloading the data, right? So how would we do that? How would we keep a record of it? Let's look inside my workflow. So I put those in my workflow. Right? This is the kind of thing that goes into the documentation for a bioinformatics project, is you got the data from somewhere. Some online server from Illumina, somebody's website, a GitHub repository. It came from somewhere. However it is that you downloaded it, you should document that. If you're on Windows, you need to include this as like comments in your file. I downloaded this file, right? For those of you who already have wget installed and working, you would just put it like that. Okay. So this is assignment 3. We've got our data files for it. We've somehow documented how we got those data files, and now it's time to start working on this. Almost. There's one thing we're kind of neglecting, or I am so far with assignment 3. I see a hand up. Ernie.
So for this project, you created a workflow. Should we do that too?
For every project, you should
Okay.
create a workflow. Yeah.
Cool.
Now, you don't have to do a shell script until later in the class, but since you already know how to do it, you can do that. A README file or a workflow, just a text file that lists the commands you used in order, absolutely crucial.
Okay. Yeah.
It's like the main learning objective of this class is how to be reproducible, and so I'm definitely going to make you do that.
Perfect.
Yeah. All right, but this project is missing something.
A README file?
What's that?
A README file?
It's missing a README file. What else?
Other directories.
Other directories. Okay, so you've already got a script that makes your directory structure for you. Okay, so I'm gonna look at my workflow again. All right, so let's see here. Maybe I'll just do nano, so it's all by itself. First line of mine, shebang bin bash. So this is a bash script. And then I just included a few lines right here. So I'm making data scripts and output. Right. Your directory structure is customized to you, okay? For this assignment, that's going to work well enough for me, so that's what I'm doing. So I'm making some directories. I'm creating a README file. Then I'm downloading the data. So that's a couple steps in my workflow right there. So let's go ahead and do that. Whether you do it interactively with your terminal and record it later, or whether you just start building a bash script now, it's kind of up to you. So let's see. I would be making directories, data, scripts, and output. Right. And when I downloaded these data files, where should they probably go so they don't clutter everything up? Into data. So that's MV for move. How would I move all three of these into data?
Can you just list all 3 file names with spaces between them after the command?
Can you
Yeah,
use
I like typing a lot.
You can use a what? One of those.
So I could just do MV ast star to data. All right, so now they're there in data, ls data. Okay. Now, if you look at my little workflow, I did the wget on those, but I gave it a little flag. This capital O, meaning here's the output file that I want this to go into. So I'm getting something from the internet, and it's going to name it the same thing it came in as. Okay. And it's going to put it right where I am. So with the dash capital O, I'm saying, actually, I want this to be output to a directory called data assignment 3 file1.fasta. All right, so in my workflow, I didn't move anything. I just had it downloaded directly to my data automatically. I already had that folder created. Okay, but it doesn't matter how you get it done as long as you document how you did it. It's okay. So if you did download these straight to your directory, then you made your data output and scripts or whatever, and then you moved them into data, you need to document that exactly as you did it. One step right after the other in the exact order that you did. Remember, if you forgot what you did, you've got history. Okay, so there it is. We've done the first 4 steps of assignment 3, and now we've got step number 5. Write a command that combines all 3 of these files into a single file called assignment3 combined files.fasta. Okay, who wants to help me with that one? How do you stick the contents of files together?
I found a way to do it, but I don't know if it's like the proper way to do it.
There's no
Okay.
right way to do. There's only wrong ways to do things.
I can post it in the chat.
All right. I love it. Of course, it's not going to work on my computer. Do you know what error that's going to give me? No such file or directory. Why?
Because there's a lowercase a assignment.
There is. So I'm going to change that. All right, so it did it, and it gave me assignment 3 combined files.fasta, but there's something wrong with this file. What's wrong with it? Why is there a 0 right here? Let's take a look at that file. It's empty. So your command still isn't quite working. I'm going to remove that.
Is it the
So
double
this-
arrows?
No, double arrows could be good. That's fine. Oh, this is rich. I am just loving what's happening right here.
It's because we are not in the directory where the files live.
You gave it a file path that doesn't exist. Okay, so to fix that, I would say data. So it knows to look inside of data, find things that start assignment 3 star and end in FASTA. It's going to concatenate everything it finds all together. And where do I really want this? I want it in my output because it's output from a command. Does that command make sense now? Okay, so since we'd already moved all the 3 assignment FASTA files into data, unless you tell it where they are, unless you use relative file paths, it's not going to work. And you thought I was just being a real stickler when I kept saying file paths are everything. They really are. So I run that. That's going to work. So now I can look inside of output, and I do have that file. And if I concatenate everything, or just print it to my screen, output assignment 3 combined files.fasta, bingo. We've got our stuff. We took 3 DNA sequence files and we stuck them together into one big one. Okay, so I did some stuff. I probably should make a note of that exact line in my workflow because it did some work. All right, anything that does some work needs to go into your workflow. All right, see a couple hands.
Ernie was first.
All right, Ernie.
Oh,
No.
sorry, that was an old hand.
Oh,
Okay.
hold
Can you? I just forgot my question. I'll ask when I remember.
Okay. So let's take a look at my workflow again.
I remember.
Oh yeah.
Sorry. So you say like copy this into your workflow. So the workflow is a shell script. So do you wouldn't you want like a list of all the commands that you do in like a README file to like keep track of what you did rather than something that you can like run? Does that make sense?
Well, the thing is that a README file and a shell script are both just text.
Right.
And so they both keep track either way. If you want to put it into a text file that you don't run, that's fine with me.
Okay.
But since I've already shown you how to start a shell script, it's kind of nice to have it in there so that you can rerun your entire analysis if you need to.
Okay.
If you mess up some data or whatever. So in mine, so you see I'm making my directory structure, starting a README. In my README, I'm gonna just have more like basic info about the project, like this is for assignment 3. Here's the date that I put it together. Here's some of the tasks. And maybe I would copy and paste the text of assignment 3 here into the README, just to kind of have like a record. And then what I like to actually do is have all the steps I took in this script. And so here's my combining those 3 files.
Okay, that makes sense. Is there a way then, my second question is there a way to, other than copy and paste, like the commands that you use, is there a way to automatically output the things that I do into that file? Or do I have to manually move each command over and over?
It works better since we're new at this to manually move everything, because not every command you try is going to work. And we're going to be playing around a lot. And so when you get it working right, save that command. Yeah. It's a fine idea to open up your workflow in a text editor, just a separate little window over here, so you can easily copy and paste between the two. Like kind of once you get it working, that can be easier than trying to go nano back and forth, copy and paste. Yep. Okay, so I've saved that. You notice that I stuck it in data rather than output, because I guess I was just being dumb, but okay, that's where I put it in my workflow, so that's where the rest of my workflow is going to look for it. All right, now you got to download a program file. So this is just a bash script that I wrote. It's really dumb, but it takes a long time to run, which is what I wanted. All right, so we can do that with wget if we have that. Otherwise, save this. It's a .sh file. All right, and so you're just going to stick it into scripts. So part of this analysis is downloading this person's script that they wrote, and so I'm documenting that. I'm getting that program file. I'm telling it I want to stick this as the output in scripts, assignment 3 program file.sh. I saw your hand earlier, Reagan. Did we answer your question?
Yeah, it was giving me an error that said I didn't make a directory called output, but I was in data, so I don't have a directory in data. Anyway, I figured it out. So.
Cool. %90 of all the errors we have in here are going to be because of we're in the wrong directory, or we typed the file path wrong. Yeah. All right. All right, so let's see. In scripts, I don't have anything, so I'm gonna go back to my workflow. Copy that. All right, so I downloaded that. It should be in scripts now because I just ran the wget. Okay. So now this project's starting to come together. We've got a folder for data, one for output, one for scripts, and we actually have a script for it. let's take a look at this script and see what it's doing. So I'm going to cat scripts assignment 3 program file.sh. Okay, and here it is. Don't worry about these first 4 lines. That's fine. They basically become standard in every bash script you're ever going to write. And so I just copy and paste them. There's the first command that's happening in this script. What's it doing? Let's see if we can figure this one out.
Is it finding our combined file for the 3 files that we just made?
Yep. And it's going to find them no matter what your directory structure is. So if you have data with a lowercase d, it's okay, because it's just going to be searching, starting 2 steps back, which is probably your desktop, for any file named that. And then it's going to send the names and the paths of all those files to a little file called tmp, just something temporary. Okay. Then it's running a while loop. We can talk about these later. But it's reading each line of that file, which would be a file name. And then it is sleeping for 5 seconds between all these steps for no reason, except to take up time. This is so that we can learn how to run this as a background process, bring it to the foreground, all that kind of stuff. This would take about half a second to run without all the sleeping, and so this gives us a chance to kind of play with it as if it were running a longer process. And so it's just looking inside those files and showing you some stuff, sending some info to you, and then sleeping. Okay, so clear my screen here. Print my working directory. Look around. From here, how do I run that file? That's that new script we just downloaded. Where is it? At least in my directory. Bash script name. Yep, Trevor's got the right idea. To run a bash script, we just say bash scripts assignment 3 program file.sh. That's it. Okay. So I'm going to run that. It is running. Giving me some output slowly. It's looking in this first file. It's going to print out the first 2 lines of that file. Okay, so this is your FASTA format. You're going to be seeing a lot of this. Okay. Then it tells us how many lines there are. And then it's going to show me each line that contains GAACC. There they are. It's not really that neat, I know, but it's just humor, this program. Okay. Then it moves on to the next file, and it does the same thing over again. All right, so this is the script running. That's what it's doing. It's deliberately taking a long time because I want to run this in the background just for practice. All right, so how do I stop this?
Control C.
Control C.
Control C. Yeah, that's my get out of jail free keyboard interrupt, command interrupt, control C. Okay, so that takes a while to run. I want it to finish, but I didn't have the patience because I wanted my command prompt back. If I look around, I've actually got that little temp file now because I stopped this prematurely before my script had a chance to clean it up. It left behind some trash. If I look at that, it's really just a list of files. Okay. Now, you won't have these three, but that's okay. How do I run this in the background? I know you know this since you read the chapter.
With the and command.
Yeah. So I'm gonna bash scripts assignment 3 and. All right. What's happening? What's going on?
Is it because there are other commands in the script, and so each of those is not running in the background?
Yeah, let's see if I can, if I stop this and I say jobs, it's just still giving me the junk out from it. And that's okay. I can control C at any time, say jobs, and you see that it's still running. Okay. So if I really wanted to stop this at this point, I control C and then hit foreground. Now if I control C and say jobs, there's nothing. So this might be a bit confusing. It's running that script in the background, but that script was still sending things to the computer. Those are going to continue to come through. Okay? That's normal behavior. You can control C on any of those at any time, and it's not going to kill the underlying script. Okay? It's still running in the background. To see what's running, we type jobs. That was still running. I had to really quickly hit Control C and foreground to bring it, and then really kill that with Control C. So let's see, if I do this again, run it in the background. Okay, it's working. Oops. Control C, kill one. I actually don't know why that's not working. That should have worked.
What is 15,747?
Jobs. Okay. So I guess the kill command wasn't working here. It was wanting the actual name of the job, which was 15,697, which I didn't have time to type because the sleeps weren't long enough. Yep. Yeah, Cody, it is this process for kill. But foreground one, that worked. They will bring it there, and now the jobs it's killed. Okay, so the rest of assignment 3 is essentially practicing on how to use that background, foreground with a long-running job, just to get you used to what this looks like. Once we start running other people's bioinformatics tools, they do take longer because they're working with tons of data, it's complex algorithms, and some of them really do send stuff to your screen. And that might be annoying. So how would we prevent it from sending things to our screen?
Could you see up to a different?
Yeah, let's send it like this to standard out.txt. And we'll still run it in the background. All right. So 2 birds, 1 stone. We look at jobs. That's running. It's running in the background. This is the process ID here. And we should have a file called stdout.txt. And we do. And it's going to just grow. As we're looking at it, if we check in again, it's going to have more lines. Check in again, it's going to have more lines. And so that file's growing. It's not overwriting itself with every new echo output from our program because we gave it the redirect and append rather than redirect and output. We gave it the 2 greater than symbols. Okay, so you can suppress all that annoying stuff coming to your screen by sending the standard out to a file. If you really, really, really don't care about the standard output and you want it to disappear forever, you can send it to dev null. This is an imaginary file on your computer system that's just a black hole. Everything that goes there is deleted. Okay. Dev is short for device. So that this is where like your flash drives live. They're in the dev directory. CD-ROMs, if people still have those, all that kind of stuff, goes to dev. And then this is just null, so we're sending it to an invisible, non-existent device, and it disappears forever. I rarely do that in practice because I think keeping a record of that standard out can help with debugging. By debugging, I mean that I rarely get things right the first time. And so when it fails, I want to be able to go back and see what the output was to see if there's any clues for kind of why it was failing. All right, so it's still running in the background. I look around, I've got my TMP directory, I've got standard out now. Maybe I should have sent that to output instead, but that's okay. It's really just for me to kind of keep things off my screen for right now. All right. Questions about this? Assignment 3. We're ready to move on. It's time to start learning some new tools for our arsenal. In particular, grep. Let me know if you want me to cover any more with assignment 3. I'm going to remove data, output, and scripts from this. I'm also going to remove standard out and TMP. So, boom, I just deleted my whole project. Except for my workflow. And this is why I like having a workflow, is that I can just say bash workflow. It's re-downloading everything, showing me my directory structure, and I'm ready to go again. So that's kind of the benefit of doing it as a workflow instead of just a README.
Oh, wait a minute. How do you show the directory structure?
I don't know if you can do it with Windows, but it's the tree command for Unix systems.
Oh yeah, I remember that. Okay,
Tree.
Yes.
If you're on Mac, you may have to do like a brew install tree. It doesn't come native. All right. So that's assignment 3. do that. I just want that documentation, what you did, and then these 3 lines of code are out of order. So let's go over grep so you can figure out how to put these in order. I'm going to go into data where I've got my 3 files there and now my combined one. I'm going to do head assignment 3 star just to get a glimpse at each of these files. Okay, so it says, here's your combined files.fasta, first few lines. Here's file 1, file 2, file 3. All right, this is a very common, for better or worse, format for DNA sequence data to be stored. And in an ideal world, every sequence takes up 2 lines exactly in your file. 1 line starts with greater than, and then is named, and that can be any name you want. It doesn't matter. Then the next line is the actual sequence associated with that name. Line 3 starts over with a little greater than. That means new sequence. Here's the name of the sequence. Here's the actual sequence. It's wrapping around on my browser here, but that is one line. If you double click it, the whole thing gets highlighted. It's on a single line. So this is the FASTA format. Again, very, very common. But we're going to use grep to kind of look inside these files. Global regular expression pattern. So we're going to grep, and we give it a pattern. GTA, GGTG. All right, so I know that that's at least in one of my, probably in all of them, but that's all right. We're going to grep that pattern, assignment 3 star. All right, what's this doing? What's the standard in, standard out, and standard error? There's always 3 streams. And they're always working 1 line at a time.
Isn't the in the file you're giving it?
Yep. So I'm giving it the files to be my standard in.
And then the out, it's all the instances of quotation marks within that file.
Yeah.
And then
all the lines, and the standard out will go to our screen.
And then the error is non-existent.
Hopefully non-existent. Hopefully the error is empty. Okay, so I run that, and boy, it's giving me a lot of output. So for each little file, it's giving me each line that matched that. Okay. So that's maybe a bit confusing because there's all these different files. So let's just try grep on the assignment 3 combined files, the one that we stuck together. This should be a bit easier to interpret because we're not doing 3 files at once. Okay, there's the output from that. It's showing me each line. What's missing from this FASTA file now?
The name.
The header. Yeah, the names of the sequences. All right, I'm gonna hit up, go back over here, and type in something crazy looking. So that's Shift 6 gives you that caret, and then greater than. All right, this is a special secret code for starts with. The caret means the line starts with greater than. So in a FASTA file, that's all the names of the sequences. So there's a list of all the sequence names in that file. Okay. It found every line that begins with greater than. Okay. How do I count how many sequences are in this file? Starting from here.
Add the -n flag? Maybe.
Nope. You're on the right track. What about this? Pipe? What program that you already know could I pipe this to?
Word count.
Yeah, lines. So 148 sequences. Now, there is a little flag for grep. It's C for count. Grep has lots of flags. Okay. One of them is C, so that counts the number of times that this pattern was matched. Okay. And because all these Unix programs, they're working with streams, one line at a time for every file ever. It's always, it reads in one line, does something to it, outputs that line, next line. Remember, this keeps us from having to load gigabytes of stuff into our memory. We're just working with like kilobytes at most at any given time for a really long line. So it's looking for this pattern. If it finds it, it counts it. If it doesn't find it, it doesn't count it. But doing this is functionally equivalent. We're just piping it to the word count, because that's our standard out. That becomes the standard in for word count.
So that gives you 148, but on the assignment 3 it says that there should be 151.
It does. Oh.
Where are those other 3 going, or what are they?
Oh, that's because this is all the files. So we're not doing the exact question for assignment 3. Yeah. So let's see here. I'm actually getting 296 on that because I've got a bunch of extra stuff. In other words, this is a hypothetical thing. Now, let's see here. We can do that. We can word count L. What would this search for?
Lines that begin with a.
Yeah. Lines that begin with a. Now, memorizing this little caret thing is worth your time. Very often, you're going to want to search for lines that begin with or end with something. All right, so let's look there. We didn't find any. Aww. Okay, a dollar sign. What does the dollar sign denote for grep? The end of the line.
Big money.
Yeah, so here we've found all the sequences that ended in AA. we do just A, well, that's not working too well because that's giving us our headers also. But all right. So you see a problem here. We've got a grep, and we said we want all the sequences that end in A. I was forgetting that all our sequence headers seem to be ending in A also because they have the primers listed there. How would I get around this with a pipe?
Maybe just the V flag for like everything that's not this, and have it start with a caret. Or not the caret, greater than.
Okay. So we've found all the lines in assignment 3 combined files.fasta that end with a $. And then we've seen the output and we've gone, oh man, well, that pattern wasn't specific enough. So let's send it to another round of grep. In this case, we use a V flag saying inverted. So find everything except lines that begin with greater than. There we go. There's our one that ends in A. So let's search for the pattern cat cat in combined files. Okay, we've got a number of those. There are some other flags that make grep even more useful than it already is. Let's say that your question is not to find the sequences that have cat cat, but to find the names of the sequences that have cat cat. What can we do there? Check out this capital B flag. Here's our output. What do you think B1 is doing?
The previous line to the next line onto your results.
Yeah, it's short for before. And so I'm saying, hey,
The
grep,
line before it.
if you find cat cat, I want you to also give me one line before it.
If you put a 2, will that give the 2 lines, or will it give the?
Sure will.
So how would you give then, instead of 1 and 2 lines above, only the second line above? Like, can you skip one? Does that make sense? I don't know if you'd ever need that. I'm just curious.
You might need that actually. This is the Wild West. You might actually need that exact situation. And so if you wanted just the line, like the second line before it, or like 2 up, let's see. So here's the actual sequence we had. Here's the 2 lines before it. That's actually kind of a tough problem. Let's think about this.
I can play around with it and see if I can figure it out.
Yeah.
I got it.
Did you use the cut function?
Well,
With
we
like
can
an
type
enter
it
being the
to
dominator?
grep again that starts with dash dash, because that's separating all our results now. And then I can say B1 dash dash, and then I can say grep invert everything except those lines that start with dash dash. And there they are. So you can chain a bunch of greps together. I find myself doing this in practice all the time. There's another program we'll learn called SED, which is awesome. And combined with grep, man, you're kind of like a wizard at that point. If you know a few flags for grep and SED, you can do all kinds of stuff just by chaining them together. So yeah, in this case, we had to find the 2 lines in front, then just take the lines in front of the separators, and then remove the separators. Oops. All right, so if we just wanted the names of the sequences to have cat, we can pipe this to another grep, and what would we do?
Sorry, what are we looking for?
Just these headers. The names of the sequences that contain cat.
So you do pipe, then grep, then in quotations, caret, and then line header.
That's it. So by combining a couple little grep tools, now we've got a list of the sequences that had our sequence of interest, whatever that might be for your project. You've got this list. You could easily then send that to a new file, right? You call it cat.txt. And so now you've got a list of sequences that have that. You could use that downstream for searching or whatever. So that should get you started for assignment 3. You should be good to go on, I think, since we walked through most of it. But for your practice, I want you to use, you probably won't be able to do number 6 or number 4 yet. That's okay. See if you can figure it out. That one takes SED. But you should at least be able to do number 1 and number 2 just using grep and paste. All right. So grep and paste should be able to get you number 1 and 2. We didn't get far enough today for you to do the whole practice, I think. You can give it a shot, but it's going to be using this command called SED. We're out of time, so I can't sit here and tell you, because I have to go teach another class. But any last minute questions for assignment 3 or your practice?
For people with Windows, should we just email you and schedule time to figure out how to get
Yes, let me see my calendar. It's going to be, I have from 1 to 2 that I can try to figure this out, and I'll just put an answer on MS Teams in our general for everyone on Windows, unless Windows defeats me and I can't figure it out. In which case, I do have a workaround in my back pocket. We've got virtual machines, so you can pretend you're on a Linux. Right. Not ideal. Things run a lot more slowly. You have to be logged in through the VPN to UVU campus, so kind of not ideal. Hopefully we can get things actually working on your computer so that you can do things at home without being online through UVU's VPN. But if necessary, we can do that.
I've got some time today, so if I figure it out before then, I'll send you a message.
All right. And Trevor says the answer. Oh, yeah. I clicked on it without reading the link. This is the answer.
That's a dangerous practice.
Yeah. this is what happened to me when I started doing bioinformatics. It's that Windows basically hit a hard wall for me on some things. It became a pain. And so I downloaded Ubuntu and I did a dual boot. So when I turn on my computer, I can pick whether to go to Windows or Linux. And a month later, I abandoned Windows forever and deleted it. Never used it since. That can happen to you too, so be careful. Right. Well, I'll run, and hit me up over the weekend if you run into snags or anything. I'll try to answer as fast as possible. I'm moving, so it may be a bit slow.